All right, awesome. So let's just get right started into this meetup. So the main mission of Activeloop is to allow you to, we're trying to build an open source community enabling data-centric AI. And we do this via Hub, which is our open source package, and also the Activeloop platform. So Hub allows you to enable data streaming, scalable machine learning pipelines, and data version control for distributed workloads. And the Activeloop platform allows you to easily access, visualize, and query data sets to build great models. So last year in 2021, we were working on building a solid foundation for this year, 2022. And we did this by rebuilding the entire code base and also shipping several features. And this year in 2022, Hub is now feature complete, and we're going to be working on creating add-ons and integrations. And we're also going to be launching and expanding the Activeloop platform. And we're going to be sharing features from that today. So I'm super excited for that. Today, we're going to be hearing from a lot of people that work at Activeloop. So first, we're going to hear about querying and version control updates from Ivo, who is our head of product. Then we're going to hear about visualization updates from Sassoon, who is the head of visualization. And then we're going to hear about the future of Hub and the Activeloop platform, so our roadmap for the future, from David, who is our founding CEO. And we're also going to hear about why Hub and the Activeloop platform is ideal for larger data sets. And then we're going to hear about what's the latest and greatest things are with datasets from Michael, who is the head of open source growth. And finally, we're going to have an opportunity to answer any community questions. So we want to make this like really interactive. So if you have any questions, feel free to type them in the chat, and we'll answer them. But if you want to wait till the end, we're also going to have an opportunity to just have like anyone ask any questions. So if you have questions, you can ask them then. But let's get started. So Ivo, if you would like to take it away for querying and version control updates.
Yeah, sure. So querying and version control are two of the, I would say, pretty major features that we released at the end of last year and the start of this year, and we're still developing them and building them out. I'd say they're in a beta phase right now, and some of you have already had a chance to battle test them, and so we'd love to get your feedback on what you've thought so far. But let me just kind of give you the overview now of what these features are like and what we think they should be used for. Yeah, so we'll start off with version control. So really our goal for version control is enabling you to version control your data sets just like you version control your code. And this can be useful for all sorts of reasons. So oftentimes when you are using your data, you might want to, for example, try different pre-processing pipelines. And you might want to separate those. So basically create a commit with one pre-processing step and another commit with a different pre-processing step, and then train your models accordingly and see what kind of differences you get. Another thing you may want to do is, for example, isolate labels from different annotations providers of different branches. So you basically send one branch to one annotation provider, another branch to another annotation provider to see actually who's doing a better job and to isolate that information without having to write tons of boilerplate code. Third point is just really general usefulness of version control, and that's basically being able to add or remove data and maintain traceability. So you can go at any point down your version history and access any snapshot of your data that you would have had to check, did something break at that point? Did somebody introduce a change that might not be so good? And it just generally helps with debugging. And then lastly, version control will enable you to maintain reproducibility of your training workflows. So what you can do now essentially is basically take the commit hash that you're running a training job on, and that's basically all you need to know to fully reproduce the data that went into that training job, which is really awesome. Now let me dig into a little bit of what that API looks like. So as I mentioned, we want you to be able to essentially do what you do with our version control, like Git for code, and actually the API is also designed to be very similar. So hopefully these commands should be very familiar. So we have commit. This enables you to create through ds.commit. This enables you to create a permanent snapshot of your data. We have a branch that enables you to create independent workflows on different branches. We have checkout that enables you to access any branch or commit hash on anywhere in your commit tree. We have log that enables you to understand who did what and when. Then we have diff, which the diff is actually a little bit unique. So we can't, unfortunately, diff data quite like we can diff code, literally sort of letter for letter. But we do try our best. So the way our diff works is actually we tell you which tensors and which indices within those tensors were modified, added, or deleted. And then last but not least, and this is something that we're still working on, is merge. So we'll be able to basically allow you to merge different branches into each other so that you can take your experimental branches and, for example, deploy them on a main branch as the ground truth for your data. And then we also have a version control UI. And the way to think about this is hub is essentially equivalent to Git. So that's where all the commands are, like ds.branch, ds.commit, etc. And then platform is the equivalent to GitHub, which is basically a user interface that shows you the history of your commits and the activity, the overall activity on your data sets in a more general way. And so we'll show what that looks like in the next slide. So this is now our version control through the platform UI. So basically what we're looking at here on the right is we have our standard visualizer for our data sets. And then on the left, we have the navigation for the version control. So you can basically select any of your commits, any of your branches, you see who created them and when they were created. And then as you navigate through this version control UI, you can immediately visualize the corresponding version that you selected on the left in the visualizer on the right. And so we wanted to make this really, really interactive so that you can visually compare what these different versions look like as quickly as possible. And then the other exciting feature that I want to highlight is filtering and querying. So, filtering and querying is just such a foundational aspect of pretty much any data science workflow. And I was thinking about it, I was like, well, why is that actually? And I think really the reason is looking at large amounts of data is just really, really hard. You need to have the power to down select data based on some sort of insight or intuition that you may have had or that may have come from perhaps a colleague. And you need to be able to really filter data down to a small subset in order to be able to effectively answer questions, because looking at data in its raw entirety is extremely difficult. And so that's what we want to do with the filtering and querying UI. You can down select your data based on user-defined criteria. That can be really useful. For example, specific understanding the quality of specific annotations. Like maybe you heard that your annotation provider didn't fully understand how to label multiple cars in an image. Then you can run a filter function and say, hey, give me all the pictures with multiple cars and these multiple vehicle annotations in this image, and you can actually answer that question. And then lastly, you can train models on subset of your data. So you might want to check out whether your model actually performs better or not on different slices of your data, and filtering and querying is really a great way to do that. And again, we have, so if we go to this slide here, filtering and querying, it's kind of similar to the version control story. Basically, what I'm going to call filtering is the thing that you do in Hub in our open source package. And then what I'm going to call querying is the thing that you do in Platform, which is our web-based tool. But at the root of it, they're both pretty much the same. It's just a different interface for effectively going through the same workflows. And so the way the filtering API works, this is now in Hub, is you can basically define a filtering function. Like in this particular example, we define a function called filter labels that is just checking. It takes in a list of labels and it just checks. It basically just returns all of the samples that meet the criteria of those samples being in the labels list that you want to filter against. So defining these functions is pretty simple, but the cool thing that we provide for you is you can decorate all of these functions with hub.compute, as we've done here. And that basically gives you the full power of parallelization, just like we have, for example, for transformations with the hub.compute and hub.eval syntax. So you don't have to worry about any of the parallel processing. You basically just take this filter function, slap on a hub.compute over it, and you can run it multi-process using those tools that we built to make sure that this runs really, really quickly. And then last but not least, so here we have the querying UI. Now we're actually querying things through the user interface, and we figure out how to do all the computations. Just keep in mind this query language is still being defined and it's being changed. But what you see here at the box on the top is you've effectively defined a filter function that is going to return to you all of the samples where the first bounding box coordinates are greater than 10. So let's say you want to filter out bounding boxes that have a specific location within your samples. You can specify that filter in this querying UI, and then return those values and see which samples met that filter condition immediately and interactively through the user interface. And actually, sorry, I was mainly looking at the slides, but now I see we have a few questions. Let me see. But can we run a SQL query? So we don't have the language isn't a SQL style language yet. Right now, it's basically a language that we sort of made up. The way we hope that you will understand what to do in that language, and I haven't shown that using UI, is there'll be a really strong autocomplete. So basically, you'll have suggestions for exactly what you need to do to make sure that you properly format a query to get the results that you want. We actually have thought about going in the SQL direction and properly making a language that has a SQL style syntax that'll work. And so this is actually really useful feedback. We'll take that into consideration. It was a little bit harder to do that for us, which is why we decided on this simpler approach for now, but we might very well go in that direction.
All right, thank you so much for those updates. And thank you for asking any questions in the chat. It's really cool to see all the engagement. And now we're gonna hear the latest and greatest in visualization updates from Sassoon. So feel free to take it away.
Yeah, thanks, Christina, and hello, everyone. Happy to be here to present the visualization updates. So the visualizer is essential part of our platform, and we are aiming to provide powerful tool sets, not only to visualize your data in a user-friendly way, but also to interact with the data and have fun while you are using your data. So having this in mind, we provide as many as possible, like new data types visualization. And the first thing we want to highlight is audio datasets visualization. So Abid asked in the chat about audio data. So the answer is yes, we can provide not only create audio data, but also visualize it through the platform. The way it works, like you create your audio dataset using Hub as usual, and you open the platform. In the platform, you are opening that dataset, and it provides like all the audio controls to listen your audio per any sample and visualize the waveforms for that. Here we have small demo. Yeah. So this is a data set for different music genres. With the, it has labels for each sample, and you can hear any sample here, and you can like go forward, backward, and stop at any place. So it's not only useful, but also fun. Yeah, another crucial data type is video. Can we go ahead? Yeah, so we also provide visualization for your video data sets. This is one of our data sets which we have. It's like hockey videos, and the labeling is it's like classification, whether the video has fights on it or not. So you can play any video, stop at any time to observe different timestamps of the video, different frames. Yeah, and yeah, and another significant part about the visualizer that is we were able to significantly increase the data fetching speed. So now the screen of the visualizer is being updated like almost immediately. So you are not interrupting while using visualizer and scrolling on different areas. Yeah. This is it, and if we have questions, yeah, thanks, Dylan.
Nice, those are really cool demos. So I hope everyone enjoyed seeing them, and thank you for presenting that. Now
Thanks,
we're going to
everyone.
get into the roadmap and the future of Hub and the Activeloop platform. But before we get into that, we have a survey that's going to be going out in the Zoom chat. And this survey is cool, but like some surveys can be a bit tedious to fill out. So if you fill out the survey, you get a chance to get Activeloop, swag. So there's your incentive. It's really short, so feel free to do that. I'll be pasting it in the chat. There's only 2 questions. And we're also going to have David go over the roadmap. So feel free to take it away.
Thanks, Christina, for the introduction. And also thanks everyone for being here. This is like all for you to give us feedback and give us direction. And we really appreciate, even if it's criticism, I'll be like, that's awesome how you mentioned this. And this is very helpful for us to understand where things are missing and where things are not. And I want to go like kind of few processes that we have in our minds, and we are heading into the direction. And that's with, of course, we start defining, okay, where Hub we should focus on and what kind of data we should typically try to become the best for storing and processing. And we have seen a lot of interest coming from video processing, and we are focusing on videos to be able to like kind of define this should be our next, in 3 months will be the primary use case for how we're going to store the data and process it, and how we're going to go and kind of take this niche and try to be the best there. And what this entails is, first of all, supporting as many codecs as possible that users are using, supporting large videos. I think this has been an issue that we have noticed, where you try to load a large video and the memory goes to super high, or it's very difficult to transfer the data. And we have a lot of, I think, already up and running issues trying to tackle this issue. And of course, another big thing that Fayaz has been leading on is actually having a random seek access to the data. The same way as you stream the data to watch, let's say, a YouTube video, you can actually randomly seek an access and then get a NumPy array, and then you can do all your processing on top of this. So I think that that's one of the key things that we have been thinking a lot, where to put Hub into which direction, because going to all directions will actually make Hub meaningless across all the dimensions. So now we actually gonna try to focus on the next 3 months, targeting the video and nailing this down, the use case. And we really appreciate all your feedback. We have heard a lot of things from the community over the past few weeks, and we will really need your help, either testing the videos or giving us feedback how we can make it better, and both on the visualization side and on the storage side of things as well. But we have seen also a lot of gains and the problems with current ways how people are actually managing their video datasets. And want to give a sneak peek as well what will be next. And we also like kind of the second top priority was our biomedical data processing. So that will be kind of a next iteration where we'll hand off. In terms of next feedback that we have received from the community and from the users is the data ingestion. So how we can make the data ingestion to be as easy as possible. We have seen a lot of trouble on like taking, let's say you have a raw data and then transforming into tensors, or we'll call them materialized form. And it has been a bottleneck for some and many to start like using Hub in its true essence. And we have Abhinav from our side that's actually going to lead this effort to be able to take the like think from scratch how we can make it as simple and as effortless for you to kickstart this, like point to a folder of all your data and then directly have an access to these data sets and start processing it using TensorFlow or PyTorch. And also like having some kind of a pointers as well that we have seen might need so some people might not need to have a kind of a data duplication, and pointing the URLs instead of actually storing the data itself, the data might make it easier or more comfortable for many users to get started with Hub. I think there's a question of what does it mean polyglot. So it's actually kind of the effort name, what we call it internally, but the main idea is that it can eat everything, it can eat anything, and formalize it and make it very easy for you to start processing the dataset. And this also includes processing data frames and tabular data and textual data we do know that there are some certain inefficiencies on each use case or each user data type, and likely we are not the best, let's say, in columnar data storage, but we are also thinking of here's an extension to multiple data types to be able to support native other formats that might be best, let's say, in tabular data storage like Parquet, or in textual data, for example, could be Arrow, Apache Arrow could be a best storage there. So these are the kind of considerations that we are thinking, and we will love any feedback or any direction from the community that has been working on this space for a long period. Okay, I'm going to the next. And I think one of the things I'm super excited actually sharing today with our community is this effort of solving one of the biggest pain points in Python, especially in data I/O. So I think TensorFlow, PyTorch, and other deep learning frameworks did a great job on solving the computational problem, like how can I run high performance computing inside Python, and how can I offload my, let's say, tensor computations to the GPUs or TPUs, and how can I scale this to multiple GPUs and multiple TPUs. But one of the things that is not actually yet solved across the whole industry is actually how to pass the data to those computations, how we can actually move the data and bring it efficiently to those efforts. So we have Andre from our team who is going to lead the building the data core IO for PyData streaming engine, and it's most of it going to be implemented in C++, and to make it as efficient and as performant as possible to go from the storage layer where the data exists into these computational layers without any major bottlenecks, and also like trying to kind of move back the bottleneck to the compute again, because the compute did so good that now the data IO is actually the bottleneck for most of the computations. And now we kind of want to do all our best to make Hub performant in a sense from the data IO and data streaming perspective. And we have this new effort at Activeloop, and also we expect the community as well to help us a lot for building the engine that's going to solve one of the biggest, I believe, PyData and Python problems with moving the data around. And this also like kind of the clean continuation with, since we have put a lot of effort, and we also have a lot of feedback from the users saying that they had a lot of issues with DCB training. I think one of the current like near short-term strategies that we have is to nail down the DCB training, and we love community help on testing out our DDP that we just pushed to the main branch. I think we have seen and heard some of the use cases where there's a concurrent need writes. We initially haven't been prioritizing that intentionally because we thought that there's kind of one worker can write all the data and then multiple workers will read. So kind of one write and then multiple read kind of a system architecture. But we now are seriously considering to add concurrent writes led by Abhinav mostly. And of course, then the other, the use case, we have the hub.compute and all the transformation layer, but they are not yet super honed in for large scale data processing tasks. And that's, I think, another effort we're going to push this to actually make it production ready so we can run large scale data processing at scale on multiple clusters. And of course, as you mentioned, I think Dylan mentioned about an integration with Spotify. Unfortunately, Spotify is not on the list on the MLOps community, but we do have a lot of integrations. We don't want to be the all-in-one tool. Actually, we want to be part of the whole ecosystem. And this really includes, first of all, trying to have like integrations with experimentation tracking frameworks so that your datasets can be tracked properly. And one integration with AMA we are going to push soon. There's some of the others that are on the roadmap within the next 3 months, including with weights and biases and MLflow. And another, I think Owen mentioned, we are not the best tool for like annotation frameworks, and we are not have no any intentions to be there. So we do have a pipeline of integrations with, including with Label Studio, Labelbox, Scale, and other annotation frameworks we're more than happy to integrate with. And of course, the deep learning ecosystem, we're trying to be push more integrations with frameworks like Keras. I think we have an integration with TensorFlow now, but it's not super optimized. It's just a plug and play integration, and we'll put another effort this month as well to make TensorFlow as fast as PyTorch that we have been working. And I know also there are some efforts from the community And feel free, of course, we can share it later, that to do some integrations with not only like file systems or like a data storage, object storage on the cloud, but also on the distributed. I'll say I'm not open too much the windows there unless we have a proper plan, but there's an exciting integration that might come from the community to deploy hub datasets on blockchain. So another thing that we are really optimizing for, and I think that's kind of a feedback that comes from not only Hobbit, but more from also other users that have been trying to use our API on the query search engine, is like, how can we make it as simple as possible to actually search your unstructured data? And Fariz is going to run this effort from our side. He actually, funnily enough, he separately he published a paper on archives. So it's a preprint on how to run queries, natural language processing queries on tables. And we're really excited about this and looking forward to let our users be able to very easily run a search on their datasets. And this includes, for us, when you upload your data, we're going to automatically compute the embeddings behind the scenes. So you don't have to use your own model. I mean, if you want, of course, you will be able to, but we will like kind of take care of the management of running these embeddings on the Activeloop platform. We want to able to let you to run a similarity search. Let's say you can click on an image and then, okay, give me all the images that are similar to this one. And then you'll get only the dataset view that contains the similar images. And the other exciting thing that I think we're all of us super excited about is being able to run natural language queries, like give me all the images that contain a box or a tree. And then it runs the search on the embedding space, brings back the dataset view that is like the top most similar items that you have seen, that you can retrain your models on it. So that's another effort. And of course, as you've seen today, it's like the first iteration with Sasun and the team on building the visual computing interface for computer vision. And we want to make our UI as interactive as possible. And that includes actually integration outside of our UI to embedding visualization in your notebook. That's the like kind of the primary cases where you can just do .ds.visualize, and then you'll actually see the window of the visualizer below. And you can start interacting with it. The next thing that we are very passionate about is about being able to real-time sync your code and visualizer. So what means that while you are developing your data, you can actually instantly see how on the visualizer, how the data is being developed. That includes running transformations. You see how the transformation happens. You're running training. You see how the training works. You add more data and the visualizer gets instantly updated. And that's one of the next things that we are working on. And of course, now coming back from the visualizer perspective is that what all Hub can do, we want visualizer to be able to do that as well without actually code intervention there. So users who are not Pythonists or they don't have much coding skills, they can actually easily interact with the datasets and start working with it. So this is like a big initiative from our side, and Sasun is heading that project. And we want with the neural search and the interactive visualization, we really believe that we can make it very, very easy for not only data scientists and deep learning engineers to be able to work with the data at scale, but also with people who are just getting started or learning or from the other domains. And there's also one Easter egg in the visualizer that we haven't yet published it on community, but I think that's one of the biggest asks that we have seen from folks to be able to visualize local data sets. And I don't want to throw this Easter egg now, or maybe should I? Okay, let me do that. So what you can do actually, if you create a data set locally on your machine and take that folder and then drag and drop on the visualizer on the UI, you will actually see your local data set being visualized on the visualizer from your browser. And there's no any network connectivity there. Give it a try and give us any feedback. I think we are going to soon launch that feature as well. But those are all major directions that we are thinking to target next 3 months and most of this year. And we will love your feedback, your involvement, tests, helping us with running tests, helping us with any development you have expertise with to actually nail this down. So I think this year we are really targeting to make help to be used in production use cases at large organizations, and we love your help helping us with that direction. And of course, yes, there's another dimension as well, making decentralized AI working as well. So thanks a lot, everyone. And today also, yes, there's also one major thing as well I want to go with you, folks, is about why we what is the main reason essentially behind the scenes why we are doing this, and what are the problems that we are facing and solving. And the first problem is that we see across the industry, and we have been focused on this for the last few years, is that we see that data sets getting larger and larger, and the way we are interacting with the data on our Windows machines, or like, I don't know, Mac OS, Linux, whatever, like as files and folders, it's become super inefficient when you're talking about, let's say, million samples or billion samples of data. And that's one of the key things that at Activeloop we are trying to make it very easy for you to work with large scale data sets, as if you're like just running a Google search or operating at scale. So that's one of the problems that we have seen across multiple companies. The second problem I've seen, and we also have seen a lot of like attempts on this solution over the past few months on making data, like basically bringing the data to the compute. So I think that's kind of the handover to the compute hasn't been yet solved. You have seen like large companies that have a proprietary solutions on solving this problem. You have seen recently some open source solutions that are trying to solve some part of it for specialized data. But in general, this problem that's like how, like the question is like, okay, what is the most efficient and effective way, given the hardware as well constraints, I can take the data from one location and bring it to the other location and plug and hand over to the compute. So that has so many inefficiencies, and I think we're super excited tackling that problem, and we believe it's one of the like next biggest things that gonna happen in the data infrastructure world. And the third thing is about actually quality of the data, and how we can do all our best building the best infrastructure for the scale, but if we don't really care about what data do we store, how do we store it, like, and what, like, is it useful data sets, or is the compliance there, is like, are there any errors in the data, then like we just like have an effort, meaningless effort basically. So the main point is focusing on understanding, even if the data sets are small, how can we make that more useful, how we can make it more qualitative. And that's the third problem that we want to prioritize as well on tackling this. And having said that, at Activeloop, we're building a solid data foundation for AI, and those are the three kind of dimensions we are going across with. First of all, as simple as possible API for creating, storing, and collaborating on AI datasets of any size. And whenever you see that the API is not simple, as Abid did, that just shout it out, and we will take your feedback and try to modify on our side. The second thing is being able to help to rapidly transform and stream data. So that's like that talks about the performance and talks about running the computations while you're actually bringing it to the compute, even though you think just bringing to the data to the compute is just a logistic issue, actually is not the case. The problem with even transferring the data, there is some compute involved, including processing, or let's say decompression. Actually, decompression is the biggest bottleneck currently. So even transferring the data from one location to another location is not just a logistic issue, and we have to be very, very careful on how we do that. And the third thing we are focused on is letting you to be able to easily and simply explore and visualize data sets for AI, so that you can actually understand what kind of machine learning models you should train, and how you should train those models, having a visual kind of perspective. And all this for you to be able to get more accurate and cost-effective AI models. And I think as a kind of a closing remark, I want to say we really, really appreciate your help through this journey. And some of you and most of you have been so much involved in helping us out. And we really value your feedback, and love even to hear more. I think one of the conversations that we had with Andre yesterday is like, hey, we have this idea like how we can quickly test it out. And the immediate thing is like, hey, let's throw this out to the community and ask them to test it out and see if this could be worked on, let's say on this edge case where some of you might have the problem. So we will expect more involvement and help from your side to push us this forward. But yeah, thanks a lot, and passing this to Christina back on continuation.
Yes, for sure. Thank you so much for those updates. And last but certainly not least, we're going to hear about the dataset updates from Mika.
Hello there. Hello there, everyone. Christina, can you actually like update the slide, please? So just escape and go back, because I was so excited to share a couple of more things.
Yes, yes, for sure.
Additional information. So very long awaited update from our side, guys. A lot of people, some of you are in this call, so I'd like to thank Sai from our community, Rasha, Tanya, and I think I saw Amal, but he might have disconnected. No, I still see him, and Parth as well. So with the help of our community, we're uploading, we have been uploading over the past 2 months a lot of computer vision data sets. So we've reached the mark of 100 data sets, and we will be launching them soon. So they're actually already uploaded to Hub. We are going through the QA currently. If you want to help us QA, so whatever we put out there is, verified, working and useful, please let me know in the Slack. But the news is that we have the, you'll be able to access in a couple of seconds, lots of popular top 100 computer vision datasets, which is pretty exciting. And I really would love to, again, thank everyone involved in this effort. In other news, on the next slide. Yeah, so we are also going to launch, we will be slowly rolling out the platform on a website that's called Product Hunt. You may or may not know this, but it's the place to introduce new products. So we really want to be successful there. If you're like a community member, please consider like registering on Product Hunt in advance. Actually, if you can do it like today, works perfectly fine as well. And the reason being, once we kind of drop you a message later within the next 1 month, it might turn out that you'll be a new user, and the new user app boards are not really impactful on Product Hunt. So I'm just making sure that if you want to support us on Product Hunt, please do so a little bit in advance. And if you have any issues logging in there, just let me know. It's just a simple Gmail sign on, so that should work pretty straightforward. And the third update, but equally as exciting, if not more. So here I posted some updates on the swag and swag design. So we finally have some swag that we would love to share with the community, and we do have multiple kind of touch points that we really want to recognize the community that we have for their contributions. I know some of you had trouble receiving swag, so I'll make sure that that doesn't happen, and everybody who everybody gets a swag basically who meaningfully contributes to the community. And you can get stickers, bottles, t-shirts. We have a lot more. It just wouldn't fit the slides, so I just wanted to share the most exciting one just by quickly unmuting yourself, because I'm very curious. Would you prefer like a white t-shirt or a black t-shirt? Because internally this has been a huge disagreement. I think it was a more heated battle over the t-shirt design rather than some of the system designs that we had. What do you guys think?
Black t-shirt.
Black t-shirt. Okay. Black. Good Lord, I'm losing.
Yes, I'm winning, Mika.
Because I really like the white one. But okay, black t-shirt it is. I think you guys have yeah, made it loud and clear that everybody likes the black t-shirt. So we're gonna have the black t-shirt printed and send to the community members. I really thank you guys for the input here. So again, if you haven't already filled in the survey, please do. Christina, I think we can bump up the link in the chat if the people haven't, so they don't scroll it. It's super short. We'll give out these stickers that you see to the right of you, and we'll just ship it immediately. And thanks again for your contributions. Like, it really means a lot to us because you help us to move forward and build something that actually matters, which is exciting. I think that's it from my side.
Yeah, that's it from us from updates. So if you have any questions at all, like, let us know either in the chat or, unmute yourself. We're happy to take any questions, and we love to hear your questions. So, don't feel shy at all. We can wait a couple minutes because for you to form your questions if you have any. But while we wait for the questions, oh yeah, go for it.
I have multiple questions. I mean, it's related to the cloud. Like my data set is still not visible. Like the main cover photo is not visible or something like that. Because I'm using older version of JPEG compression, something like that. And oh, what else? Yeah, I think when I like use any other JPEG compression, my data set like explodes, like the storage like 4 times. It increased 4 times the storage, and I don't think that should happen. Even with DVC, it doubles the storage, so it have a metadata and it have like real data. But I don't know what's really going on with the compression, or I'm using the wrong compression or something like that.
Avid, would you be able to send us maybe some of the sample images that blew up?
I did share it on Slack.
Yeah, I remember. I remember. Yeah, Abid, you posted this issue on the Slack. So the problem was with JPEG 200 compression, and it's on our roadmap, and we will have support for them like soon. I guess in this month we will have visualization for these formats.
But the storage size also increased. Like that shouldn't happen like 4 times. Like my storage is, the original data set is like 80 MB. Like these are like weather images, like classification, and it increased to like 380 MB, like something like that. And I was like not sure what's really going on, like where is it duplicating or what's really going on, but I couldn't figure it out.
We can look into that on the hub side. Perhaps what was happening is if you basically use hub.read and there's a mismatch between the compressions, then we end up decompressing, recompressing the data. If there's a match, what should have taken place is basically the bytes in your images just should have been written to the chunks, therefore producing no change in no change in size. But it sounds like for some reason maybe that didn't occur. We'll look at the samples exactly on the hub side and then see what's going on there.
Okay, thank you.
But by the way, I think that the second question that you had in the very beginning of what you said was that with the thumbnails for the
the thumbnail is not showing for
that's a known issue. So we're working on like we actually know how to fix it, and we just need to run
even for the audio data set. I don't know why it's not showing.
Actually, don't know.
Do you allow like custom thumbnails so that it becomes something attractive? Like we can just select our photo. Like,
would you expect to upload your own thumbnail?
Yeah.
Oh, okay. That's a good idea. Yeah.
Very interesting. Yeah. Cool.
Should be much easier compared to what we are doing. Give you an upload process.
Much easier.
Yeah, so just for background, what we're gonna have, and it's kind of sort of built, but it doesn't quite work, so which is why you don't see it yet, is there's gonna be basically a pipeline so that if you upload a data set to Hub, we're gonna run some post-processing scripts that pull the images or videos or audio, depending on what the underlying data is, and then build the thumbnail grid that you see for some data sets. So the reason that's not taking place right now, because it's not fully working, but it will work in our product after our product launch. But yeah, that's actually really good feedback. If you, we thought that people wouldn't bother uploading thumbnails, hence why we built this pipeline. But it's actually a lot easier if somebody just gives us the picture that they want. So we can certainly add that.
I just want to say, like, people who really like uploading open source data set, they take a lot of attention on the details, like adding license information, adding information, how they collected, attribution. Because I've been uploading data on Kaggle, and I really make sure that I have everything in, like, the thumbnail is attractive, the data set information is correct, and I'm not violating any rules, because I want to, like, it's called like reputation, like someone is uploading something, it's attached to its name, like the person name. So yeah.
Okay, awesome. Also, just another comment, I think you might also find this useful. Right now, you know, to the left of the visualizer, we have a dataset details page that has some fields that you can edit. That is going to change to Markdown. So you'll essentially be able to create whatever kind of page you want on the left side, and you'll have a lot more freedom basically to add any information that you want as a part of the data set beyond just the data itself.
The Markdown supports which version?
Pardon me?
Which version is that Markdown? Like the version of the Markdown.
Oh,
is it similar to GitHub?
I actually am not sure, to be perfectly honest with you, but I can follow up with our engineering team who's building it now, and we'll get back to you.
Okay.
Or maybe if they're on the line, Sasan, do you know by any chance?
Yeah, it should be similar to GitHub, what GitHub does.
Perfect. Thanks. Any other questions, guys?
Last question. I'm really sorry to ask all the questions.
You're fine.
So the Markdown, you have mentioned Markdown. Are we allowed to have, like, add metadata information, just like license information, but it's hidden, just like Hugging Face is using, like they allow you to add the tags, like the keywords, and it shows in an interactive way that you can click and explore, and it also shows the various models that were used to create that model use this data set to relate, and a lot of metadata and evaluation metrics, and how good this data set is, and how like those metrics is the loss, the accuracy, and all those things, F1 score can be added, so that people know that this data set is used for multiple models, and so the usability increase of that data set if the people start to see that they have a lot of matrices and it have been run, like various things. Yeah.
So we definitely we are exploring the tagging. How sophisticated the tagging will be is up to discussion. And with regards to the second part of your question, definitely we so if you I send a link for MNIST. This is like an example for the documentation that will be in place. So we really want to aggregate any information that will be useful for people to make a decision whether or not they're going to use this data set, you know, to train their models. Ivo, do you want to jump in if there's anything else to add here?
Yeah, I think that was the gist of it. I think what you summarized, but Abid, just one more thing. So you're saying you'd want almost like the data sets to have metrics of how much they're being used by other people and like what other people are doing with them?
Yeah, and how let's suppose someone trained a model and they have really good metrics using this data set. So if you go paper with the code and you go for state of the art, you will see that the model ranking of the model and the data set that were used, and a lot of people, you can see the code, you can see everything, you can click on it, it will take you to that person repository or that person model. uh, so it's just like making sure that this data set it's not static, it's saying something like a lot of models were trained on this data set, and this data set have performed on this model, this you understand how many matrices, and so it increase the usability of this data set. So I'm just giving you example like why a lot of people use like Coco data set or these state of the art data set again and again and again. Why can't they use other, there are similar data set? Why? Because a lot of models were trained on these state of the art data set, and they have proven that due to the matrices and the people are beating that matrices to produce better results on the similar data set. I'm just saying that's why these data set got like famous, these open data sets.
Okay, yeah, thank you for that feedback. We haven't done that yet, but that's a great thing for us to consider.
Nice. Okay, thank you so much for all the questions and feedback. And if you have any other questions or feedback, like feel free to like message in the Slack community. We love to hear from you. And so this meeting has been recorded, this meetup. So if you could repost it on socials and tag us, that would be amazing. We would really appreciate it. That way, like more people can learn about Hub and Activeloop and what we're trying to build. And thank you everyone for showing up today and hearing what the updates are for Hub and Activeloop platform.